In this video, we're going to look at higher accuracy forward finite difference for the first derivative. And all I'm going to mean by higher accuracy is we're going to include more terms from the Taylor series. Now, technically for f prime, we kind of took a shortcut. We skipped over the Taylor series part and just thought about it as the slope of the secant line. Okay. But this time we will actually use the Taylor series for our first derivative here. And let's go ahead and evaluate this Taylor series at x is equal to x sub I plus 1, and we'll also let a equal x sub I. And we actually did this in the last video. I'm just going to actually copy our results and paste them right here. And for some reason that didn't paste very well. Let me fix it. And we're actually also going to want the forward finite difference formula for the second derivative that we had derived. But before we use that, let's rearrange this equation here just a little bit. Okay. But what this means is this is going to be a little bit less work than the last one. Okay. Well, let's go ahead and we are going to solve this one for f prime of x. So this should look like f prime of x sub I is equal to, okay, and so we're going to subtract a lot of this stuff over. So we're going to have f of x sub I plus 1 minus f of x sub I, okay, and also a minus f double prime of x sub I times h squared over 2. Okay. And then plus dot dot dot. Or actually I'm going to say minus dot dot dot. Okay. And we want to divide each side still by h. All I've done is I moved everything over. I still need to divide each side here by h. So that's going to end up looking like all this over h. And is what I should do from here is see if I can simplify this in any way. And I think we can. I think we could then rewrite this as f prime of x sub I, and then this is equal to f of x sub I plus 1 minus f of x sub I all over h, and minus f double prime of x sub I, okay, times h over 2, right? One of those h's is going to cancel. Okay, let's move on here. So the next thing we're going to want to do is take our second derivative formula that we had gotten previously. Let's go ahead and write that down here. Okay, and I'm just going to paste it right here. Okay, and we're just going to make a little substitution. This is going to go right there. Let's go ahead and do that. So this gives us f prime of x sub I is equal to f of x sub I plus 1 minus f of x sub I all over h, and then minus this thing times h over 2. right, this is all over h squared, and then again times h over 2. Okay. All right, so next move here, we're going to combine some terms, but this is the formula we're looking for. We just need to simplify it. I'm going to note here that we're going to lose an h here because we have an h squared down here. And so what that means is this denominator is going to end up being 2h. So I'm going to try and add these things together, but in order to do that, I'll need that common denominator 2h. So I'm going to just multiply this first fraction here by 2. And I should be a little bit more specific. I'm going to multiply it by 2 over 2. Okay, so there's that. And let's get to work over here. So then this is going to look like minus, or how about we distribute our negative? How about we say, yeah, let's distribute it. Okay. And then we can add them together here in a minute. Again, that denominator is 2h, and then we'll have a minus f of x sub I plus 2. Instead of minus 2, we'll have plus 2 f of x sub I plus 1. And then finally minus f of x sub I. Okay. And now if we were to add these together, this is going to be our final formula right here. We get f prime of x sub I is equal to, and let's start off with the x sub I plus 2 terms. I'm going to have a minus f of x sub I plus 2. Okay. Let's look at the x sub I plus 1 terms. If we were to combine those, that looks like that's going to be a 4 f of x sub I plus 1. And then lastly, the x sub I terms, that looks like that's going to be a minus 3 f of x sub I, and this is all over 2h. Okay, and this is, again, a forward finite difference formula, and it's forward because we're estimating the derivative of x sub I using 2 points in front of it. All right, so what we're looking at here is our textbook, and I just want you to see that we've derived actually some of these formulas in these tables here. Let me go back up actually first. So our first, I'm going to go back even actually one more page. Let's do that. Okay. So here we go. The first set here is on page 554, and these are our forward finite difference formulas, and you can see that we have the same 2 first derivative formulas. In fact, this is the one we just came up with. And you can see it's actually more accurate than the one above it. And again, this is expected because we use more terms from the Taylor series. You can actually also see the second derivative formula that we derived. But you could imagine that we could do a similar process to come up with all these little formulas here. And these are just the forward finite difference ones. If I go to the next page, we have backward finite difference. Let me get there. There we go. Backward finite difference formulas. Okay. And again, you have the errors here on the right. And then finally on the next page, here we go. We have the centered finite difference formulas, and these are typically more accurate. Okay. And the only other thing we have left is tomorrow I'll have you all watch a video that discusses how we can combine some of our approximations for our derivative and get a more accurate approximation from that. And that's actually what you're seeing below here. The video will be about Richardson extrapolation.